Okay, so you need to read through those notes for yourself. Most of them are very self-explanatory. I mainly want to talk about what's on the back side of the notes, the heating and cooling curve. So you are going to see a graphic that looks something like this. This represents the temperature, and this is heat being added. The heat being added is being added constantly the whole time, and it's showing what happens as time goes on. If you start with a solid, and down here would represent the solid. This next flat portion represents where it is both liquid and solid. This curved line, represents where there's liquid only. This flat portion represents liquid and gas, and this part up here is where there's gas only. A lot of people think that as you add heat to a substance and undergoes phase changes, that the temperature constantly rises, and that just is not the case. The only times the temperature is changing is when you're in one phase only. Notice the line is slanted here and here and here, where there's only one phase. And that's because all of that energy is being used to convert those particles into faster moving particles. Not fast enough that they're actually being pulled apart, but they're just causing the speed to increase. And remember, temperature is a measurement of average kinetic energy. During these segments, where there's a phase change happening, then all the energy is being used to pull the particles apart to make the phase change happen. All of that is explained right underneath the graph if you want to read it again. But it's important to understand these different segments and to understand that during a phase change, there will be absolutely no change in temperature. So when your water is boiling, if it's boiling at 100 degrees, it will continue to boil at 100 degrees until all of it is gone. Then the gas can then jump up higher.